This is the Hyperion Solutions investor pitch submission for the Martian Autotrophic Containment Unit for the 2015 Conrad Spirit of Innovation Challenge. Currently there are 6 missions on Mars. Our goal is to allow for the continued exploration and eventual settlement of the Red Planet. Colonizing Mars requires a reliable source of food which cannot be brought exclusively from Earth. At the current rate, it costs approximately $10,000 to put a pound of payload in space, meaning that in 2 years it would cost approximately $27 million to feed one person.
We aim to solve this issue by growing plants on Mars. Furthermore, if missions to provide food fail, it would be catastrophic for the settlers. By aiding the colonization of Mars, we aid the production of an escape route for humans if a catastrophic event occurs. Plants cannot grow on Mars due to harmful ionizing radiation and the varying temperatures from 20 to minus 125 degrees Celsius. Also, it is currently unknown if Martian soils can sustain plants.
Specifically, plants need nutrients, as seen in purple, energy, carbon dioxide, oxygen, and water. To solve these problems, we've designed the MACU, designed to work on Mars, but adaptable to the Moon. The MACU is designed to be used in multiple units, which can be set in various arrangements to fit the terrain as shown. The MACU is fitted with monocrystalline solar arrays to provide power to the system. The top 2 panels can be opened to gain access to the sealed growing tubes beneath.
The growing tube consists of the growing area and the water reservoir. The reservoir takes in a small amount of oxygen to oxygenate the water nutrient solution. This is then pumped out of the reservoir and sprayed over the plants. Also pictured in the tube is the CO2 intake, and on the opposite end is the O2 removal system. This oxygen will be harnessed for human use. To raise the growing tubes to harvest the plants, astronauts can simply lift the tubes.
Now seen is the outside of the harvesting apparatus on a single growing tube. It consists of a sealed sliding window with the harvesting arms represented as squares.
Pictured here is the airlock in which the harvest will be placed, and as seen to the right, this airlock can be opened, filled, then closed again, allowing the atmosphere of the tube to be contained. The reservoirs will pump water into the walls, where it is stored and delivered. According to Bernoulli's principle, the system eases the delivery of water, decreasing energy needed. The piping sits between insulation and heating to maximize surface area.
Pictured below is the heating pads from the top view. The center of the MACU contains the growing tubes, and in between them is the components cabinet containing the electronics for the system.